This momentary current has little practical value. However, if we now connect the solutions, the charges in the solutions will become equalized and the metals or terminals will be charged. We will then have an unbalanced condition of the electrons in the metals capable of producing a continuous flow of useful electric current. All of the work performed by electricity requires a flow of current. So let's see what principles are involved when current flows. There are three related to the flow of electricity. They are pressure or voltage, current intensity, and resistance. First, let us consider pressure. With nature always trying to maintain an electrical balance, there is a tendency for any negatively charged object to throw off or repel its excess of electrons, and for a positively charged object to attract electrons. This urge to maintain an electrical balance is potential electric energy. And since this potential energy is a repelling and attracting urge caused by opposite charges, its force or pressure is equal to the difference in the charges. It is called the difference in potential or potential difference. The unit of pressure or potential difference is the volt. The voltage then is always the potential difference at the negative and positive terminals of the source of the electric energy. It represents the difference between the number of extra electrons at the two terminals. And when a suitable path is provided, the potential difference causes the electrons or current to flow from one terminal through the conductor to the other terminal. To explain how this works, let's review the action of the atoms and their electrons in a piece of metal, where we saw swarms of electrons moving freely in all directions about the atoms. Substances in which this takes place are good conductors of electricity. If an outside electric pressure or voltage is applied to a conductor, the electrons will move predominantly in one direction. The effect is that electrons move from the negative to the positive terminal. This is the electric current. The unit of electric current is the ampere. 1 amp, now hold on to your hat, 6,300,000,000,000,000,000 electrons passing any given point in 1 second. Current, or amperage, then is the number of electrons that pass a given point in a given time. And now the third factor.